I'm in the middle of giving you 3 examples of showing how functions are discontinuous at a point. And the main way to do this, we're going to find a sequence that converges to C, that's C right there, but f of that sequence is not going to converge to f of C. And I have 2 examples so far that I showed, and my third example is g of x is going to equal 1 if x is rational and 0 if x is irrational, and I'm going to show it's discontinuous at 0, even though it's discontinuous at a whole lot of points. So to draw the graph of this, boy, heaven help me. At 0, I know that the value is 1, and at 1, at 2, etc. In fact, at a whole bunch of rational numbers, it's 1, but at a whole bunch of irrationals, it's 0. So I can't really draw the graph. This is roughly how to think of it. It just is bouncing back and forth. So what do we need? We need a sequence x of n that goes to my point of discontinuity, which I'm choosing to be 0. It could be a whole bunch of things. But then I also need g of x of n does not go to g of 0, and g of 0 is equal to 1, since 0 is rational. So I need a sequence that goes to 0, but g of that sequence is not going to 1. So here's a non-example. Here's a sequence that doesn't work. Again, this won't matter, because I just need to find one that does work. So here's a non-example. Again, I'm going to choose my favorite sequence that goes to 1, or that goes to 0. 1 over n, that goes to 0. Well, let's see what g of that sequence is. Well, g of that sequence is g of 1 over n. G of 1 over n, oh, 1 over n is rational, so that means that I always get 1. So that goes to 1. Oh, but that's equal to g of 0. So I've not shown anything with this non-example here. I'm trying to show it's discontinuous, but I didn't. But I'm going to give you an example now of how to show it's discontinuous. So instead of choosing 1 over n, if I chose, say, 1 over pi to the n, let's assume that all powers of pi are irrational. This is going to go to 0, because pi to the n is getting really big, right? Pi squared is roughly 10. Pi to the 4th is going to be about 100. So this is going to 0. But then what happens? I need g of x of n, and I'm hoping that this does not go to 1, but that's equal to g of 1 over pi to the n. Oh, but assuming that's irrational, that's going to be equal to 0, because irrational numbers go to 0. So that's a sequence containing only 0, so it converges to 0, but that's not equal to 1, which is equal to g of 0. So here I've shown that this function is irrational at, or not irrational, it's discontinuous at 0. So this is the name of the game. You keep trying sequences until you find one that works. If you can't ever find a sequence that works, maybe you should start thinking about the function being continuous there. But this is how you basically show discontinuities. Find a nice countable sequence, and then you find another nice countable sequence that's related by taking f of that sequence that does not converge to f of c.